So again, I like first to go through the high level before jumping into the details for each and every single parameter or function of the BCB in details. So as I have done in the last session, I like first to cover the BDCP header as you look into the left side here. But the BDCP header is more simple compared to what we have discussed for RLC. It's having much less content compared to the RLC. So first of all, you need to understand the header because the header will make it very clear whenever you go deep dive for any even signaling analysis or even when you try to understand the function of any of the BDCP layer or TCP or RLC or even MAC. So the left figure here, if you look into here, it's similar to the RLC. This is you will find in the header usually, like if you are opening Wireshark, you will find, for example, DC or D or C, and this is exactly same as RLC. DC, this like if it's the value is 0, this means this is a control BDU, means it's asking, for example, for signaling acknowledgement. While it's one is data BDU, and our main focus today will be about the data BDU. And this is just reserved for future use. It's not using for anything. The most important is a BDCP sequence number. BDCP sequence number is having similar functionality compared to the RLC sequence number, and sequence number in general is being used to be able from the layer itself to be able to track the packets or the sequence number associated to the packets. So the layer will be able to track this packet in case if it's like received out of sequence from the receiver, it will understand based on sequence number. It can make a retransmission based on sequence number, reordering based on sequence number. So sequence number is very important, especially for the for retransmission point of view, and if in case if you have any packet loss. And the third one is data, and you have this MAC-I. This MAC-I actually is used for the integrity and ciphering. It's like a kind of values being added for use for integrity protection and ciphering, and this is optional for the data radio bearer. It's not must, it's optional. It can be configured, can be like enabled or disabled for data radio bearer, but it's must signal radio bearer. So this is like the overview for the BDCP header. And again, the sequence number can be exactly same as RLC, 12 or 18 bits. And this is also decide the window size. If you don't remember window size, you can go back to the first session. And here, this is just a high level, like about the functions which can be presented. We'll go through each one of them in next slides. So let's move next slide and see what we have. So here, I just quoted in the left figure here, the figure from the 3GPP and also the function, the bottom left here, if you can see the bottom left, and the top left here, this is the function of the transmitter and receiver. And if you look into here, it will find that it's exactly the same. At the first part, at the first function of the BDCP, which is must, this is must be done from the transmitter side. You'll find that the transmitter usually having something called transmission buffer and sequence number allocation. This means that first thing the transmitter will do once it's received the packet from the upper layer, which is the TCP or coming from application moving to CP, IB, then it reaches to BDCP. The first thing will be done from the BDCP layer. It will be assigning a sequence number, again, to be able to track this packet, and also it will help the receiver to do this kind of reordering and so on. So this is the first thing. And there is something called transmission buffer. Once the packet arrives to the BDCP buffer, it will start a related timer called a discard timer. We'll be discussing that part in details in the next slides, but this is just the first thing the BDCP will do. The second part, which is optional, it's not must, it's header compression. The first one is must be done. Second one is optional. It's header compression based on robust header compression, and header compression can be done to reduce the packet size. And reducing the packet size in general, especially if you reduce the IB header, reducing the packet size in general can bring like a better capacity, and also can sometimes improve your blocker rate because you can have more energy per bits if you reduce the size of the packet. This also will be discussed in details. And the right figure here, if you look into the header compression, you have a different profiles, and I will be showing how to check this from the drive test. This can be enabled based on the vendor. It can decide which profile to like to enable. Usually, the header compression is being used for the voice data, like for example, voice over NR or VoLTE. But if you're speaking about 5G, it will be voice over NR. So voice over NR, for example, it will be highlighting for profile 1 and 2. So if you found from the drive test profile 1 and 2 is enabled, this means you have header compression for the voice over NR. And you can also do it for TCP IP and also other multiple profiles here. And this is again depend on the vendor side. Then moving to the next two parts, will be just highlighting in like here. I will not go through them in details. Integrity, protection, something. This is very easy, but all the others will be going in details with live visualization example. You have integrity protection and ciphering, and this is, if you remember in the header, we mentioned something called MAC-I. In general, the integrity protection and ciphering is done by the receiver and transmitter, with like a communication done between both of them, and the receiver uses the integrity protection key, for example, to verify packet authenticity and to prevent, for example, RAG insertions or like any attack or something like that. And the integrity and ciphering in general, both is mandatory for signal radio bearer 1 and signal radio bearer 2. This is like always on. It cannot be disabled, okay? But it's optional for data radio bearer, DRB, okay? While this is the integrity job, the receiver is using that part to verify the packet authenticity. While the ciphering actually is used to improve the security in general, and this is by helping to ensure that only the intended of the reception is able to interpret the data. Like only the receiver which I'm directing the data from will be able to read this kind of data. Any other devices cannot do that. Only the intended device. So this is the main idea of integrity protection and ciphering. Okay. Header will be adding in general. Then after moving forward here, you will have this kind of number 5, which is split bearer or routing or duplication. And this is usually happening mainly in the non-standalone. If you have a non-standalone and you decided to do a bearer split through transferring data from for example, if you speak about option 3x, so you would like to transfer data from 5G to 4G through the through interface. We'll go through the details of that part for all these 3 points. And the last part, and the most important as well, related to reordering, and this is the reordering and in order delivery mainly done at the receiver side. This is mainly done at the receiver side, and there is a parameters to control all of that. And also, we're speaking about something called the PDCP retransmission, how the PDCP in general is doing retransmission. If you remember last time I highlighted that retransmission can be done by this TCP, can be done by PDCP, RLC, and MAC as well. But the BT is kind of different compared to the others because it's not retransmitting a specific packet. We'll go through details for each of these points in next slides. Now let's go through one of these functions one by one to cover it in details to give you much better understanding about it. Before going to the last each of those function, if you look into just try to code the table on the left, this is actually the parameters where you are going to find it in the 3G layer 3 messages. Like this is kind of all the parameters which controlling all these functionality. This is 3GPP parameters. You can find that there is something called discard timer. This is related to transmission buffer. We're speaking about that part. This is related to the sequence number, whether it's 18 bits or 12 bits, and the header compression. It will be highlighting whether it's used or not used for uplink only. And in case if used for uplink only, by the way, as per the 3GPP, if used for uplink only, this means it will be only supporting profile 6. All the other profiles can not be supported, which is TCP/IP compression. Okay, so this is just a side note. And integrity protection, also again, this is must for SRV1 and SRV2 cannot be disabled. That's why you find it here. It's under the data radio bearer. And you have out of all the derivative, we'll be discussing about that part. And these 3 parameters in between here, this is mainly for, again, A and C, not for 5G standalone. Then you have the reordering and ciphering disabled.